In this tutorial, we are gonna learn how we can create beam stirrups with Dynamo instead of in Revit. We're going to write a whole Dynamo script from A to Z, and because it is geometry heavy, we are also looking at the basic geometry transformations in PowerPoint first. So let's get started. Alright, so this time we're not starting right in Revit or in Dynamo, but instead in PowerPoint. Because this time it's going to be very complicated, it's going to be a lot of geometry, lines, rectangles, vectors, yeah, just transformation of geometry in Dynamo. So first we want to simplify it here in PowerPoint what we're going to do, and then later on we can understand all the nodes and how they interact with each other better. So first off, we have this beam and we want to fill this beam with those rectangulars, and those rectangulars are volumes that represent rebars. And so it is kind of complicated because every beam looks a bit different. It has sometimes different width and heights, sometimes it has different angles. So we need to find a parametric way to make our script applicable for everything. So the way I found here is that we're basically first selecting this cross section, this face. So I'm just gonna take it. So it is kind of like a cross section, rectangular. And from that cross section, basically, we need to find the cover, because the rebars need to be inside the beam and they're not allowed to be on the edge. So we're getting the parameter from Revit, and then we're simply getting from that face all of the edges. So that means all the lines from the cross section, and from there we are basically offsetting those lines inside of the element. And then we basically get our rectangular, that's the center line of our rebars. And from there, we are gonna just get those corner points. And with those corner points, we are creating the new rectangle. And then it's important, once we have that center line, we can create our first rebar, but we still need a vector to distribute the whole rebar set along this line. So again, we have this face, and we are just simply going to find out this vector, and then we're distributing this first rebar along this vector until the end of the beam. So not much more theory. Let's have a look how this is gonna look like in Revit and in Dynamo. I just want to align it a little bit so we basically can see what we have. And what I have here, it's basically, I already modeled those rebars in Revit itself, and now I created some beams that all have a different angle. So we can then later on see that our script actually works for any angle and for multiple beams. But this video will only showcase the stirrups, and in later videos we're gonna go ahead and make it applicable for maybe 2 or 3 or maybe 50 different beams. Okay, let's start. So as always, those of you who have seen some videos of me, I always like to start off with the end. And as in other videos, we need the structural design package. In order to get that, simply go to packages, search for a package, then this package search window opens up. It's syncing right now, and then you simply look for structural design, and here we go, and then you simply install it. All right, I've done that. So it's already here and I don't have to install it. And what we're gonna do is we open up the structural design package. Then we want to use the rebar section, create, and we want to use the command from curves. So there we go. And this is basically our end result. Like this one is creating the first rebar of our rebar set. Just gonna group this so we have a nice color. And we can see that we have a lot of inputs. And those inputs we're gonna do now. First off, I want to start with the curves. It's the most tricky part, and that is basically the part I was showing here in PowerPoint. So first off, as I said, we want to select the front face and simply look for face. We're selecting this face. This node looks like this. Click on select and then choose one of the faces of the beams. Important, it needs to be this start or end face. Once we have that, what we first want to do is we are getting what we saw also here. We're kind of getting this cross section here. Let me just delete that. So this is our first step to get all the edges of this face. And we can do that by perimeter curves. This one. Use it and then have it as the first input. Surface perimeter curves. Alright, let's run and see what we get. Takes a little bit. We get a list of 4 lines. And now we just want to see that. I'm gonna just hide the preview of the face so we can actually focus on our lines. Zoom to fit. And there we go. So when we select this one, it's highlighted blue. The next thing we're gonna do is that we are offsetting our curve. So that is being done by curve dot offset. Yeah, once you get more into Dynamo, you know those commands pretty well, and this is the fastest way to just look for the nodes. So basically what we're doing here is we're taking our curves and offsetting them here, and now we need a distance. And the distance will be what I said. We have our cross section, and then we need this distance to the center line of the rebar, which is basically the cover plus other rebar layers plus the half the diameter of our rebar. So that is basically what we're gonna do. Let's have a look first at the beam, because we get a parameter here that is giving us the cover of the beam, and that is in our case basically this one, 30 millimeters rebar cover. And yeah, you can select different ones for different surfaces, but usually you have the same one in most cases. And so we're trying to get that value from that parameter, and so for that we need, of course, to select the beam, and we're gonna do that. Select model element. So we're gonna select our element here, and then also in the structural design package we get this properties rebar host, rebar diameter. There we go. So we connect those two rebar diameters, we can run it, and in our case, let's see if we selected the correct one. Oh, sorry, not rebar diameter, that was my bad. Let's go to the properties and look for the host cover, this one, and select it, run it again, and then we get those values that we just had a look at. So for top exterior, bottom interior, and other, we have the 30 millimeters. So I'm just gonna take one of those with a code block, just call it A, oops, take the top one, yeah, and then now we can do some math. So let's keep it simple and say this one, like our our stirrup will be the first rebar after the rebar cover. So with that, basically we can already do a new code block. We say we have the first input, which is the rebar cover, and then plus, let's call it, and we can call it whatever we want, plus, sorry, I'm struggling with my keyboard here, plus the half the diameter, half. So now we need, first of all, the rebar cover, which is A, and then also the diameter. So now we need to find out which rebar diameter we are going to use. So we can select here rebar bar type and select one of those here. So I'm gonna go ahead and take H20, and then we also need the rebar diameter node, rebar diameter here, connect those two, run it, see what we get, and we get 20. So now we can take those 20, insert it here, run it, and see that 30 plus 10 must be 40. And now we can take those 40 as a distance and run it. And now we can see that it didn't work nicely. So it just offsetted it, actually not inwards, but actually outwards. And for that I found a way. It's working, but it's not the best one, I admit. So what I did, I just took the start point of all of our curves here and define my new rectangle. So here I'm just taking from our curves, from those ones, the start points, and then create a new rectangle by corner points. And then you basically create a new rectangle by yourself, and yeah, you're not dependent on how Dynamo is already defining those edges. Okay, let's run it. Let's see what we get. We get a new rectangle. We use that as our curve. And now we see that it was in the wrong direction, so we just give this a minus. Run it. Oops, nothing happened. Oh, now it happened. Yes. So now we got our rectangle offsetted inwards of the cross section. So far so good. And basically what we can do with this one now, in order that it works for our create from curves, we need to explode this rectangle. This is also something that just needs some experience with geometry and especially with rebars. But at one point you always find those ways out. Alright, so the first input is now given. Let's just go on with the second one, and that is rebar style. So let's just look for rebar style. There we go. Use this node, and we're going down here and selecting stirrup. You can also use standard, but because we're creating a stirrup, both works, but I think the nicer way is to also use the style stirrup. Now rebar bar type, we already have that input because we needed the diameter. Use this one. And then start hook type. Alright, so just look for hook type. There we go. And for a stirrup, in that case, for now we don't want a hook type. So I'm just selecting none, but you can change that and use 150 degrees or whatever. And now I'm just having control and take the same input for my end hook type. Select it here. Next input is start hook orientation. So we're gonna look for that again. Hook orientation, select that one. Drag it to the beginning so we have everything in order. Just select anything you need that input, even though we don't have a hook, and put it into both start and end hook orientation. Now host element, we already have that because we had to select our beam. Select model element. That goes into here. And now the last input is the vector. So that is the normal plane where the rebar line lies. And so what we have here basically is our cross section. And I hope I draw this correctly, but the vector is normal to our rebar plane. So that means that we have we are looking for this vector. So we need a 90-degree angle between the vector and this plane. So basically 90 degrees from here to this one, to this line, and 90 degrees from this to this one. And we get that simply by using the start face, which is here, and we are looking for the normal vector. Normal, let's look for it. Surface normal. Here we have plane. Normal at point. So in order to, I always use the midpoint. So normal at parameter actually is what I use, not at point, because that is just quicker. So U and V vectors, if you just use 0.5, it's the midpoint. So select face, have that as an input, use that vector and plug it into this input here. Okay, so now let's try it and see if it works or if we get any error messages. And there we go. Here is our first stirrup. Now, one thing that I haven't mentioned in our PowerPoint here is, that actually it's not as it's supposed to be, because when we look here at our shape, it's 51, and actually the stirrup shape is 31, the correct one here. So a very easy fix that I'm using, it's not the nicest one, but again, this tutorial should just be a help and it's not supposed to be the solution. I think you need to learn the skill sets to create more and more Dynamo scripts for rebar automation by yourself. But a trick I'm using is that I just set the rebar shape ID here. So I have the rebar, I plug it in, and I know that I want 31 for my rebar shape. Run it. And now it didn't work. Let's just remove this one and execute it again. Let's see if we have still all the inputs. Yeah, rebar bar type needs new one, H12 this time. Run it, and now it looks much better. You see, now it's much more yeah, not rounded, but it's more, yeah. Look, and if we go here, it's also 51, so that didn't work. I'm sorry. Let's go back here and see why it didn't work. Warning, set ID expects argument. Expects Revit element. Oh, okay, yep. You see that you always make mistakes, and it's just how you move on. So I just used an integer, but we actually need an element, and we simply select rebar shape. I use here rebar shape 31. Let's go ahead and delete this again. I'm gonna just drag this over to the start. We probably, yeah, for some reason this rebar type doesn't want to stay when we delete an element. Let's run it again. This looks better. Let's see. Yes, and this time it worked. And I've already used this workaround also for spiral rebars for piles. So yeah. All right. But now what we need to do after this one here is actually to distribute it along this edge. And that is what I explained here. We need this vector. That's why we had to define it in our rebar creation. And now we need to figure out how long this line is to actually distribute it along there. So but first I want to show what we're going to use. So we need to go to layout, and then you see here all the types that we can also use in Revit. And I'm going to go to set layout as maximum spacing. That's the one that I prefer to use. The input must be a rebar, and spacing. So I use usually code blocks for this. We can use this because I'm not using it. And now my spacing should be 200 millimeters. So spacing means the distance between each rebar center line. But now we need to find out an array length. And there's, with the API or with some nodes, you can find out the length of the rebar probably. But what I did actually, I translated the geometry of the model, of the beam, basically into a Dynamo geometry with the node element geometry there. Then I exploded it to get the surfaces. There we go. So we can have a look what we've done so far. So now we have the whole element. Just gonna hide it so we can see everything else better. And then the geometry explode, and what we get here is 6 surfaces. And from here, because it's in a list that doesn't look nice, I'm just gonna flatten that list. So here, list by the amount of 1. What that does is, yeah, now the list is a bit nicer. From here, we're getting the surface. We're getting the surface perimeter curves, as we also did before. Perimeter curves. And then from here, we're calculating us the length of those curves. Must be somewhere down here, curve length. Okay, now let's take a break, run it, and see what we have done so far. Yeah, so basically here again, we created a lot of lines out of those surfaces. So those are the surfaces. Let's preview. Let's hide them. Also this one. Preview. Yeah, and so basically here we got the boundary lines of those surfaces. And now we got a lot of lengths. And yeah, so there we can see that we get a few values. So we can see basically here that this curve must be the cross section, so the front face, whereas this one is probably the top or the side face, because we have here much higher values of 14 meters, 14,000 millimeters. Now we're just taking the maximum item. So that defines the length of our beam. List, run it. Let's see, now we get, yeah, a lot of items. Like the quick fix is just to take the maximum item of that list again. But you could also play around with those levels. Yeah, but here we have it now. So now we basically have the 14 meters, and I'm just gonna, yeah, just make it simple. Take that value, use some space at the end and at the front. So now we have 13 meter 80 centimeters, and we use that now for the length of our rebar set. Then we have some other inputs, but they have already default values, so we actually don't have to use that anymore. And now we can run it and see what is going to happen. And something not so nice is happening, that it's actually distributed in the wrong direction. So what can we do? We can actually reverse the vector of our create from curves. So reverse, let's find the vector, this one here. I'm using this input, putting it in here, use that vector to put it in, and now it should be fine. Okay, what happened? Oh, I think because we deleted it, yeah, the rebar bar type was 0. Let's use H12, run it, and now we can see that this worked very nicely. And we can also check, yes. So basically this at the end, we could make this a bit smaller, like 100. So then it's a bit longer at the end. Now, but the important thing about this whole workflow is that we now can use this script for different beams with different angles. So we're just gonna select those and run it again. And the new rebar set is being created. Now this video would be too long to show how we can use this Dynamo script now and transfer it into a Dynamo player script, and then also you need to rewrite a bit of the script to use it for multiple beams at the same time. But we're gonna do that in the next video. But for now you saw how you can use the Dynamo geometry, make your own geometry out of it, and in this specific case make stirrup geometry out of it, and then bring it back into Revit and actually create elements. I hope this tutorial was useful and is helping the community. As I already said in the end of the demonstrational video, the next tutorial will be about the longitudinal rebars in beams, and after that there will be a tutorial about the automation of rebars of beams. So we're going to pack both scripts into one, write a little bit different things in the script, and then put it also in Dynamo Player so we can actually leverage it and use the script at the same time for multiple beams with different angles and different cross sections. So stay updated on my channel. I hope it was fun. For me it was fun, and I see you in the next one.